Chapter 10-4, Perimeters and Areas of Similar Figures. So if you recall the definition of similar figures, that means their angles are congruent and their sides are proportional. Okay, basically one figure is a bigger or smaller version of the other one. All right, Theorem 10-7, this is perimeter and area of similar figures. Okay, recall the definition of scale factor. It is the ratio of the side lengths. It says if the scale factor of two similar figures is A to B, then the ratio of their perimeters is A to B, and the ratio of their areas is A squared to B squared. So let's do an example. Problem 1. The trapezoids at the right are similar. The ratio of the lengths of corresponding sides is 6 to 9 or 2 to 3. Okay, they just reduced this fraction. 6 divided by 3 is 2. 9 divided by 3 is 3. But anyway, the ratio of the corresponding sides is 2 over 3. All right, so that's basically the scale factor. All right, so if you look at the drawings here, these trapezoids are similar. One is smaller than the other one. Okay, so they just did 6 over 9 and reduced that fraction to get the scale factor. What is the ratio, smaller to larger, of the perimeters? Well, we just learned a minute ago, if the scale factor is A over B, then the ratio of the perimeters is A over B. All right, the ratio of the sides is the scale factor. And they told us it was 6 over 9 or 2 over 3. So the ratio of the perimeters is the same. So there's nothing to do for the ratio of perimeters. It's just the same thing as the ratio for the side lengths. It's just 2 over 3. Now for part B, they want to know what is the ratio, smaller to larger, of the areas. So for the areas, you take the ratio of the side lengths, or the scale factor, same thing, and you square the numerator and denominator. So we're going to do that with 2/3. Okay, we're going to take the numerator and square it, and the denominator and square it. All right, 2 times 2 is 4, and 3 times 3 is 9. So that's it. So the ratio of the areas is the square of the ratio of the side lengths. Okay, please pause and try the same thing on Got It problem number 1. All right, two similar polygons have corresponding sides in the ratio of 5 to 7. What is the ratio, larger to smaller, of their perimeters? All right, since they asked for the larger one first, that is going to be 7 over 5. Okay, obviously they gave us the ratio of the side lengths with the smaller one first. But for part A, they said larger to smaller. All right, so I just put the larger one in the numerator and the smaller in the denominator. So that's it for part A. Part B, what is the ratio of the areas, larger to smaller? All right, so it's going to be the same thing, except you have to square the numerator and denominator. So it's just going to be 7 squared over 5 squared. All right, 7 times 7 is 49. 5 times 5 is 25. So that's it. All right, it says when you know the area of one of two similar polygons, you can use a proportion to find the area of the other polygon. Problem 2, the area of the smaller regular pentagon is about 27.5 centimeters squared. What is the best approximation for the area of the larger regular pentagon? All right, let's take a look. So we have the two similar pentagons here. All right, let's start by doing the scale factor. And that is the ratio of the side lengths. I'm going to keep the side length of the small one in the numerator. Okay, so the side length of the small one is 4. And the side length of the big one is 10. Okay, you can write centimeters if you want, but they're just going to cancel out. And reducing that fraction, 4 divided by 2 is 2. 10 divided by 2 is 5. Okay, so that's the scale factor. But we're dealing with areas. So let's find the ratio of the areas. All right, I'll do it in a different color. The ratio of the areas, remember you have to square the numerator and denominator. So take the 2/5. All right, that's going to be 2 squared divided by 5 squared. Okay, so 2 squared is 4, and 5 squared is 25. All right, so the ratio of the areas is 4/25. All right, so now we can set up a ratio and proportion. All right, once again, I'm going to put the small one in the numerator, and I'll put the big one in the denominator. Okay, so for the areas ratio, it's going to be 4/25. And then for the actual area, they said the small one is 27.5 centimeters squared, right? They said the area of the small pentagon is 27.5. So, for the numerator of the small one, I'll put 27.5. And the one we're looking for, the area of the big one, I'll call it x. All right? This fraction is the ratio of the areas. And this fraction here is the actual area. All right, so we're just matching up the fractions. And as you know, you just cross multiply. All right, top times bottom is 4x. Bottom times top, 25 times 27.5. All right, and solving for x, you just divide both sides by 4. Cancels here. And I'll do this on the calculator. Okay, and rounding off, I get 171.9. All right, and the units for the original area were centimeters squared. So this is also going to be centimeters squared. All right, so 171.9, let's check the choices. And the closest is going to be 172. All right, centimeters squared. Okay, please pause and try got it problem number 2. All right, it says the scale factor of 2 parallelograms is 3/4. The area of the larger parallelogram is 96 inches squared. What is the area of the smaller? All right, let's see. First, let's do the ratio of the areas. All right, all you want to do is square the ratio of the side lengths. All right, so 3/4 is the scale factor. We're just going to square that. All right, so the ratio of the areas is going to be 3 squared over 4 squared. So that's just 9 over 16. All right, and then we're going to set that equal to the actual areas. It says that the area of the larger parallelogram is 96. All right, clearly we put the larger one on the bottom, so the 96 is also going to go on the bottom. And the one we don't know, we're going to call that x. All right, so this first fraction was the actual ratio, and the second fraction was the actual areas. All right, and of course from here you just cross multiply. Top times bottom is 9 times 96. Bottom times top is 16 times x. All right, solving for x, divide both by 16. Cancels here, and I'll do this on the calculator. And I get x equals 54. The units on the first one was inches squared, so this one would also have to be inches squared. All right, and that makes sense. They said the area of the smaller parallelogram, so of course we had to get something less than 96 since it's smaller. All right, problem 3. During the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables that they donated to a food pantry. Next summer, the city will let them use a larger plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original. How many bushels can the student expect to harvest next year? Okay, so we want to find out how much bigger the area is. All right, so the scale factor is 2.5 because they said corresponding dimensions or corresponding sides. So we want to find how much bigger the area is. So we'll do the side lengths or the scale factor first. They said the new plot is 2.5 times more than the old plot as far as the scale factor or side lengths are concerned. So I'm just going to make the ratio 2.5 over 1, okay, because the new plot is 2.5 times more than the old plot as far as length and width. All right, now for the ratio of the areas, you just square each one. All right, so that's going to be 2.5 squared over 1 squared. All right, and 2.5 squared is 6.25. All right, and of course 1 squared is just 1. So the new plot is 6.25 times bigger. All right, and that is in terms of area. The area is 6.25 times bigger. So if the first time around they got 13 bushels out of the smaller land, and now this one is 6.25 times more, then the new amount is just going to be 6.25 times the 13 bushels. So now they should get 81.25. All right, I don't know if you can get 0.25 of a bushel, so it'll probably be 81. Yeah, it says students can expect to harvest or about 81 bushels. So yeah. So instead of 81.25, we just round it to approximately 81. Okay, please pause and try Got It problem 3A. All right, it says the ratio of the sides is 3 to 5, and the smaller one is 250. Let's see. Okay, the ratio of the sides is 3 to 5. So the ratio of the area that's going to be 3 squared over 5 squared. So 3 squared is 9. 5 squared is 25. All right. And it said the smaller window was 250. How much should the larger one cost? All right. So I'm going to set that equal to 250 divided by x. All right. So the first fraction is just the ratio. And the second fraction is the price. Okay. Obviously, the price increases based on the area. So the ratio of the price should be the same as the ratio of the areas. All right. And of course, the numerator is clearly the smaller one. And the denominator is the bigger one, right? And that's what they asked, the area, the price for the larger one. So once you get it set up, it's easy. You cross multiply, 9 times x, top times bottom. And then bottom times top, 25 times 250. All right, and solving for x, you just divide both sides by 9. It cancels here, and I'll do this on the calculator. All right, and rounding off to the nearest cent, I get approximately 6.94. So that would be in dollars, of course. So $6.94. So, when you know the ratio of the areas of two similar figures, you can work backward to find the ratio of their perimeters. All right, so now we're going to go the other way. Example 4, the triangles at the right are similar. What is the scale factor and what is the ratio of their perimeters? All right, I can tell you right now, those are both going to be the same thing. We learned at the very beginning, the scale factor is the ratio of the sides, and that equals the ratio of the perimeters. All right, the ratio of the sides equals the ratio of the perimeters. So whatever number we get for the first question for the scale factor, it's going to be the same answer for the second question, the perimeters. Now, in the diagram, they give us the areas, okay? So we can write a ratio of the areas, and we're going to do something to find the ratio of the sides. All right, recall that in the beginning, we said that the ratio of the areas equals the ratio of the sides squared. Remember the A over B? And we want to find the ratio of the sides. So what is the opposite of squaring something? Well, that will be the square root. Okay, so if I take the square root of both sides, the ratio of the areas, and the square root of the ratio of the sides, the square root undoes the square. Okay, so basically, if I just do the square root of the ratio of the areas, that will give me the ratio of the sides. All right, so that's what we're looking for, the scale factor. That's the ratio of the sides. So let's do the ratio of the areas and take the square root. All right, for the ratio of the areas, let's put the smaller one in the numerator. All right, they gave us the areas. The smaller one is 50, and the larger one is 98. They're both in centimeters squared. All right, so the smaller one is 50, and the bigger one is 98. All right, you can write centimeters squared, but they're just going to cancel. So reducing that fraction, 50 divided by 2, that's 25. And 98 divided by 2, that's 49. All right, so this right here is the ratio of the areas. So if we want to find the ratio of the sides, we have to take the square root of that. All right, so the ratio of the sides that's going to be the square root of 25 over 49. All right, and when you take the square root of a fraction, you take the square root of the numerator and denominator individually. All right, so do the square root on the numerator and denominator individually. The square root of 25 is 5, and the square root of 49 is 7. So that is your final answer. All right, so the ratio of the sides is 5 to 7. So that is basically the scale factor. Okay, and that also equals the ratio of the perimeters. All right, so this right here is your final answer for both questions, the scale factor and the ratio of the perimeters. So if you have the ratio of the areas, you take the square root, you'll get the ratio of the sides, which is the scale factor, and that will also give you the ratio of the perimeters. All right, please try got it problem number 4. And remember to make this a fraction with these two numbers. All right, reduce the fraction first and then take the square root at the end. All right, so we established we're looking for the ratio of the perimeters. We established that the ratio of the perimeters equals the square root of the ratio of the areas. All right, I'll put the smaller area on top. So the smaller area is 135, and the bigger or larger area is 1875. All right, if you wrote feet squared over feet squared, they would just cancel. So let's reduce the fraction first, okay? They both end in a 5. So I'm going to reduce this, divided by 5, and divided by 5, top and bottom. All right, divided by 5, I get 27 over 375. I know 27 is divisible by 3. If you do 3 plus 7, that's 10, plus 5, that's 15. I can divide 15 by 3. Okay, so these are both divisible by 3. You don't have to reduce it all the way, but it generally helps. Okay, 27 divided by 3 and 375 divided by 3, that's going to be 9 over 125. All right. So that right there is the ratio of the areas. We need to take the square root to get the ratio of the perimeters. All right, so the ratio of the perimeters, that's going to be the square root of the top and bottom. All right, square root of 9 over the square root of 125. Square root of 9 is just 3. And the square root of 125 is the same as 25 times 5. All right, so that's 3 Square root of 25 is just 5. And if you take the square root of 25, that's just 5, and you have radical 5 left over. Now, I know you're not supposed to have square root in the denominator, but this is not really so much a fraction as it is a ratio. Okay, so that right there is really the final answer. You can multiply top and bottom by radical 5 if you like, but the ratio is still going to be the same thing. So that's what they asked, the ratio of the perimeters, and that's what we got, 3 over 5 radical 5.